The main difference between this integral and this integral is that this one can be integrated in one step and this one can't. Now, can you identify what the difference is between these two? You might notice there's a 2y up here. And that's really important because if this 2y were not here, if y were not on the top, it doesn't even need the 2 there. But if the y weren't on the top, you'd have really big issues. And we're going to solve this integral in just a second. But I'm going to solve this one in just 2 seconds. So all I need to do is rewrite it like this. I'll go integral of 2y k lambda and then x squared plus y squared with a negative 1/2 right here. So that way I can just add 1 to this. I'm going to use the, the power rule for integrals. I'm just going to add 1 to this. And so I'm going to rewrite this like 2y k lambda x squared plus y squared. And then I'm just going to add 1. So it's going to be 1/2 this time. And then I'm going to divide that by, the reciprocal of the power. So times 2 divided by 1. I'm going to put this in parentheses. And then I'm going to divide, what is the derivative of what's inside of there? Oh, it's 2y. So I'm going to divide that by 2y as well. And that way, these things are going to cancel. And I'm just going to get the answer, 2k lambda square root of x squared plus y squared. And that is the answer. Of course, you have your limits, L to 0. You can go ahead and just plug L in for the y. And so you'll get the answer, x squared plus L squared. And minus 0, I guess you could do that as well. So minus k lambda square root of x squared, that will come out, and blah, blah, blah. So you could sort of simplify this down a little bit, but we're done with the integration. The integration happened right here. In one step, done. But it's not so easy when you're looking at it like this, when you don't have the derivative on top. Or just even just the y. Just the y would be just so nice up there. It doesn't have to be the 2y, just the y. That way the y's will cancel. You can figure out what the constants are going to be. But you see, on this side, we have to use a little bit more of an interesting technique. So, okay, so when you see this kind of stuff, x squared plus y squared, or like squareds and stuff, you kind of want to remember your trig substitution. Because isn't there like tan squared plus 1 equal to secant squared? Something like that. So if we were going to be able to transform this into just straight up secant squared, you could take the square root of that and it'll just be secant, right? If you can somehow isolate this double thing into just being one thing, then it's easy to square root that, right? So let's say that we are going to be integrating this y situation. So we kind of got to manipulate these y's. We're going to say that y equals x tan u. And because of that, now we can plug in the y over there. We're going to get stuff like this. So like x squared tan squared u plus x squared, which will just simplify into x squared times secant squared. And then this is a u in there, of course. You got a square root there. So this is just going to simplify to the integral of k lambda divided by x secant u. Now it's going to be a little bit easier. We have the dy still. So let's figure out, if we were to go dy, aren't we just going to get x secant squared u du? So that's what we're going to plug in for dy over here. So then we're going to get the integral of x secant squared u divided by x secant u, and then there's the du. I'm not going to change my limits of integration yet. It's still going to be in terms of y's over here, so I'm not doing anything there. But these are going to cancel. And so we're going to left with the integral of secant of u. And that's cool. I mean, you could remember what the secant integral is, and you could get an answer, but you might not. So how would you do this? All you need to do is multiply the top and bottom by secant plus tan. And if you do that, you're going to get some weird stuff. So you're going to get secant squared u plus tan u divided by secant u plus tan u. And then this is in du still. But I'm going to say that v equals secant u plus tan u. And now we're getting really close to the answer. I'll do the dv here because that's going to be equal to secant u tan u plus secant squared u dv. Now allowing me to replace this whole thing again with something like v on the bottom, and then the top is literally, there's this whole thing, secant squared plus tan u. Oh, I forgot a secant u right here. Secant u. There's an extra secant u on there. But yeah, this whole thing with the du included gets replaced by dv. And that's it. Okay, so now this integration limit is still in y's. Y equals 0, y equals L. I haven't changed this into v's or anything. So what I'm going to do is I'm going to switch this v, because we know the integral of 1 over v is just going to be ln of v. So I'm going to change v's into like y's. So it's technically ln of secant u plus tan u, isn't it? And what were the u's again? Let's go back to over here. I'm going to draw a little triangle over here because we have this expression that says that y over x equals tan of u. And if we go over here, y, x, this is x squared plus y squared, square rooted. We know that the tangent, blah, blah, blah. So let's try to put this into these terms. We have secant u plus tangent u. We're just going to try to figure out this answer here. We have the ln of secant u plus, we already know tangent u, it's y over x. So let's put that over there. And now we can try to solve for secant. So what's secant? Well, I know that secant is 1 over cosine. And what is cosine? Cosine is x divided by the hypotenuse here. So square root of x squared plus y squared. And so now I could plug this in. Well, I got to switch it first because it's supposed to be the reciprocal. So for secant, you're going to flip it. But you're essentially going to be getting ln of the square root of x squared plus y squared over x plus y over x. That'll, of course, simplify to one denominator. But let's finish this in the last little piece right over here. We're going to plug in the y's now. Because remember, y is supposed to be 0 and L. So you could just basically say that it's like ln of the square root of x squared plus L squared plus L squared divided by the x value over here. And then you could also do that again because you have to plug in the zeros now for y. But if you did that, you'd get ln of like square root of x squared divided by x. And that's just the ln of 1, which is 0. So this is just going to go away. So this is our final answer. After all of that work, we finally get the answer, which is very complicated to get. But yeah, you could see how this one was amazing and easy because there was just the y in the numerator and it just made everything really easy. You can integrate it in one step and there's your answer. But over here, we had to do a whole roundabout way of solving this with secants and tangents and stuff like that. And it's not that much fun.